All right, summation notation. What do we got here? We have this sequence. I'm going to zoom in a little bit here. Okay, we have this sequence 2 minus 4 plus 8 minus 16 and plus 32. Okay, so we're asked to write this as summation notation, which is going to look like this equation right here. All right, and this equation essentially, it looks kind of funky. You have this big E, which is sigma, and it stands for sum. And we have this I at the bottom, which is the starting value, otherwise known as the index, and it's the first term number. And then we have B on the top, which is the ending value, the final value that you plug in, or the last term number. And then you have your f of I, which is just the expression. And essentially, this is summation notation, and it's a way to add up all terms without having to count every single term. It's just a really compressed way of doing it, so we can do it really efficiently and clearly when it comes to having lots of numbers in calculus or even in computer science and in other situations like that. So we're going to use this formula to figure out how to write this equation above in summation notation. So first, let's just take a look at this real quick. So the first thing that you may notice is that we have some alternating signs, and we call this an alternating sequence because we have a negative and a positive and a negative and a positive, kind of acting like a light switch. And it can look, really intimidating when you first look at this. So in order to deal with that, let me just grab a different color here. And we're just going to pretend that they don't exist at all right now. And we're just going to focus on the bare bones, the constant numbers 2, 4, 8, 16, and 32. Okay, so the first thing that we want to do is actually write what's called a term number above these numbers that we have. So I'm going to write term up at the top. And I'm going to define this 2 as the first term, the 4 as the second term, the 8 as the third term, the 16 as the fourth term, and 32 as the fifth term. Oop, this is messing with me. Okay, so all I did was just add a term number above each constant that we have, all right? And so essentially this is what tells us where we are going to start and where we are going to end. And if we take a look, remember how we mentioned that I down at the bottom was the starting value, otherwise known as the first term number, right? So we can already kind of start this by writing this beautiful yet wonky symbol, sigma. And we can start by putting the first term number down at the bottom, which is 1. Now, in order to use term numbers, we also define them as variables. So I'm going to put I equals 1. And it'll make sense why as we continue working through this problem. Because we're plugging in essentially a number each time for I in order to get the equation that we need to sum up everything very cleanly. Again, we'll go through this, it'll make more sense hopefully. But in terms of variables, you can use whatever you'd like. I'm using I, but you can use V or N or an ice cream cone or a dog, just as long as you're consistent with it, okay? So at the bottom, I have I equals N. I'm actually gonna make these term numbers pink just so we can really clearly see them. All right. And if you remember, we said the b, which is the value on top of the e, that's a terrible b, it's all wonky. The b on top of the sigma is the ending value or the ending term number. And as we can see, the ending term number is 5, right? So we can just put that on top. Look, we're already like basically done, right? Okay, so the next thing that we're going to do is we are going to try and find what pattern is happening here. 2, 4, 8, 16, and 32. What's going on? So let me see if I can actually move this. Oh, I'm going to move this down. Perfect. And so 2. What's going on here? How do we get 2? So I'm seeing, if I have base 2 and I raise that 2 to the power of 1, oh, just erased on me, I get 2. If I keep the same base and I raise it to the power of 2, I get 4. 2 to the power of 3, I get 8. 2 to the power of 4, I get 16. And 2 to the power of 5, I get 32, right? So you could see this as, 1, 2, 3, 4, 5, 6, 7, 8, all the powers, but I'm also seeing it as a term number. All I'm doing is I'm taking the base 2 and I'm raising it to the term number that we assigned to it. And that's how I'm getting the numbers in the sequence, right? So with that being said, our expression, or our f of I, that's going to be plugged in here, well, we have, what's staying the same, right? All of our 2's, I'm feeling Cosmo and Wanda, so we're doing pink and green. All of our 2's, our bases are staying the same, right? So that means we can put 2 as the first part of our expression, and it's being raised to the term number, which we already defined the term number as the variable I, right? So we're just going to raise it to I. And this works because if we put 2, if I equals 2, then 2 to the second power is 4. And that's what we get here, right? This is the second term number that we're using. And we get in the sequence the number 4. So it checks out, right? Perfect. Okay. And remember that this number down here is just telling us where to start. If we were trying to figure out a certain number in the sequence, where do we start from? And that's what the I is saying, essentially. So that's kind of why I like to split it up into 2 different parts. Let me just erase that, put it back. I equals 1. Okay, are we done yet? Almost, because we need to go back and figure out this alternating sequence. What is going on? So right now, our expression is close, but it's not done. Because sure, we can plug in 2 for I and get in the sequence 4, but how do we get it to be negative 4? And how do we get, if we plug in 4 for I, how do we get that to be negative 16, right? Well, here is a formula. I'm going to shift over to the right again. So we have 2 formulas over here. And we have a to the n equals negative 1 to the power of n. Now, for simplicity terms, because I already defined my variable as I'm just going to cross this out and put I here. They use the variable n, right? But I'm using I. Okay, and you can, again, make that any variable that you want. So it'd be -1 raised to the power of I for odd number terms that are negative, and or actually for even number terms that are positive. So what this means, if we go back over to our sequence, and it's telling us terms, it's giving us, we're looking at the terms here. We're not looking at the numbers in the sequence, which can be kind of confusing. So we're not looking at if this term right here, or if this number in the sequence is even or odd. We're looking at the term number, right? And because this is term number 2, and there is a negative sign in front of this 2, it's a negative number. Same thing with this, negative term, -4. So we have both 2 and 4, which are even numbers, and they are negative. Okay, and does this check out with what we said? Even number terms positive, so we are not going to be using this first formula up at the top. Let's take a look at what the second one says. It says odd number terms are positive and even number terms are negative. So we are in fact going to be using this formula right here. All right, and all we're gonna do is we're gonna plug that in before the 2 to the I. All right, so I'm gonna erase this briefly. We're gonna put it back, no worries. And get a different color here. So it said plug in -1 I plus 1, and then multiply by what we had earlier. I'm not gonna put this in parentheses. 2I. And this is in fact our expression, our in summation notation. And this checks out because, let's see, let's just start at 1. With I equaling 1, let's just start at 1. And if we substitute 1 each time we see I, we should get this positive 2 number up here, right? So let's go ahead and do that. So we have I equals 1. So -1. 1, again, we're just subbing in 1 for I, 1 plus 1 using this expression, times 2 times 1. And that'll get us -1 squared plus, or times 2, which will get us a negative to the second power is a positive. So that's going to give us 1 times 2, which equals 2. So that checks out. Perfect. What if we plug in 4 for I? What's gonna happen there? Well, we should get -16, right? So let's plug in I equals 4 this time. -1, 4 plus 1, again, just using what we wrote over here, times 2 to the 4th power. And this will get us -1 to the 5th power times 2 to the 4th. And then -1 to the 5th power is indeed a -1 times 2 to the 4th, which we already established was 16. And therefore, we get -16. So this is our final answer in summation notation. This is the formula that you would use to add up everything at one time. You'd find the sum of all the numbers in this equation right here. All right, so this was one of our problems for our summation notation series. So thank you very much for joining me, and I will see you back at the next one.